Next, Nilesh. Nilesh.
Yes, sir.
So, what is the expression for an isobaric process to calculate the work done? Yes, Nilesh.
Yes, sir.
So, what is the expression?
So P1 V1.
For an isobaric process,
So P into V2 minus V1.
P into V2 minus V1. So, that is your expression to calculate your work in an isobaric process. Next is Prajat Rai.
Yes, sir.
So, what is the work done in case of an isochoric process?
So zero.
It's zero. So, why it is zero?
Because it is vertical, sir.
Vertical in the sense there is no area under it. So, isothermal work done is given by
Area is
six
zero.
different expressions. Yes, Prajat. So, isothermal work done is given by six different expressions. The first one being P1 V1 into ln of V2 by V1. And the second one is P1 V1 into ln of P1 by P2. Okay. And the third is in terms of P2, P2, V2 into ln of V2 by V1. And fourth one is P2, V2 into ln of P1 by P2. In terms of temperature, it is mRT into ln of V2 by V1. And it is mRT into ln of P1 by P2. Okay, remember all this. There is no confusion in remembering this, I guess. It is always V2 by V1 or it is P1 by P2. And this P1 V1, P2 V2 will just accumulate that thing. So even the MRT also. Next is adiabatic work done. That is from 1 to 2. Adiabatic work done is given by Niharika. What's the expression? Pratish Suvarna.
P2 V2 minus P1 V1
Okay, can I
minus
just
gamma.
take it as P1 V1 minus P2 V2 divided by gamma
Gamma.
minus 1?
Yes.
Yeah. And for the polytropic work, I can just take it as P1 V1 minus P2 V2 divided by N minus 1. Okay. So these are the different expressions that we have learned. Okay. Okay. So just take a screenshot of this if you need, because all the process formulas have been listed clearly. Okay, we shall go to a problem now. We shall try to solve a problem. Okay, done.
Sorry, sir.
Shall
I mistakenly got exited.
okay, no issue. Okay, have you taken a screenshot? Fine. So just take the problem number 1. Consider gas contained in a cylinder as a system. The initial pressure is being 210 kPa and corresponding volume is 0.04 meter cube. Calculate work done when the volume of the gas increases to 0.15 meter cube. Case 1. By heating pressure at constant pressure, you can just eliminate this. By heating at constant pressure, okay, And second thing, the pressure varies inversely with the volume. The pressure varies inversely with the volume. So there are two cases for this, and you have to judge which one is this. Okay, one is case one, and the other is case two. Okay, you can just eliminate this. By heating at constant pressure is the first case, and the second case is pressure varies inversely with the volume. Okay, let us solve for case one now. So, what does case one say? How is the process being carried out? He is heating the gas, okay, at a constant pressure. So if he is heating the gas at constant pressure, so which process should I consider it as? Which process should I consider it as? Because I'm heating the gas at constant pressure.
Isobaric.
So considering it to be isobaric process. Okay, isobaric process. Now we shall decide what is the initial and final states. First, you have to draw the PV diagram. Okay, of an isobaric process. You know that it would be a horizontal line. Yes or no? So it is in a horizontal line like this. Now, where is my state 1 and state 2 have to define whether my state 1 is here and state 2 is here and the process is going in this direction. That I have to check, or my state 2 is here and state 1 is here and the process is going in the reverse direction. I have to check the facts right. Okay. So for that, what I have to do is I have to read the statements of the problem very carefully. Now, consider the gas in the cylinder as a system. The initial pressure is being 210 kPa. Okay, he has mentioned about the pressure. So let us try to formulate a table. Right? Let us try to formulate a table so that the things get clarified and identified easily. Now I will mention here as state 1. Okay, and the other thing as state 2. Okay, I make a two separate columns for initial and final. Now, the first parameter is being the pressure, and second parameter is the volume. Now, help me to fill this. What is the value of P1? What is the value of V1 given in the problem? What is the value of P2? And what is the value of V2 given in the problem? So just looking at the problem statements, I expect you to tell this. Yes?
P1 is 210 kilopascal.
So P1 is 210 kilopascal, correct? That is right. So what about P2? What about P2? Any information regarding P2 is given in the problem?
Unknown.
Unknown. Can I say, suppose, if this is my state 1, okay, and this is my state 2, that is, this is 1 and 2, both the state 1 and state 2 have the common pressure, is it? Because it is isobaric. So can I just directly write it as 210 kPa straight away? Because it is isobaric? Yeah? Can I write it as such?
Yes, sir.
Okay. So once I have written the pressures, now I have to decide the volumes. Okay. So at state 1, what is the volume? At state 2, what is the volume? So let us look into the problem statements for that. Volume is the initial pressure is being 210 and corresponding volume. That means it is initial. Yes or no? Initial is state 1. So initial is how much? 0.04. So just write 0.04 to be the initial pressure. Okay, calculate the work done when the volume of the gas increases to 0.15. That means 0.15 will be the final state. That means the volume is being increased. Yes or no? The volume, if it is increased, it should go towards the positive side of the x-axis. So that's why this is state 1 and state 2. Clear? Any doubts? Any doubts, guys, up till now?
No, sir.
Okay, fine. So now give me the expression to calculate the work done from 1 to 2, which is isobaric in nature. So what is the expression? You have just discussed it to be P into V2 minus V1. Why it is just P? Why not it is P1 or P2? Because it is isobaric. Your P1 will be equal to P2 equal to P. All the values are the same. You can take the things. So 210 kPa, you have to substitute in terms of Newton per meter square, the pressure in terms of Newton per meter square, and volume in terms of meters cube. Okay, because since you have to follow certain standards units, so that whatever answer you get will be of a standard thing. Okay, now if I do so, what happens? So pressure in Newton per meter square, so it is 210 kPa, in the sense 210 kPa, in the sense it is how much? 210 into 10 to the power of 3 Newton per meter square, is it? So Pascal is nothing but Newton per meter square. So shall I substitute it? So it is 210 into 10 to the power of 3 now. What is V2? V2 is 0.15 meter cube. Already it is in the standard value, so just substitute it 0.15. Minus V1 is how much? 0.04. Just calculate the things. Whatever you get, you will get in the form of joules. What is the value? So meanwhile, keep taking and keep solving along with me in your notes, because I think the time is very short and I may not have enough time to give you to write the things up. Okay, so that's why as and when I just solving, you two be solving on your notes. Okay, yes, give me the answer, guys.
$23.1 kilojoules.
23.1 kilojoules. So can I take it as 23.1 into 10 to the power of 3 something, as in the joules? So after that, I can write 23.1 kilojoules. Is the value correct and it is same for everyone? Just check. Is the value correct? Okay. Shall we move on to this case 2 now? So in case 2, he says, let us just decrease the things. Wait a minute. Okay. Now, in case 2, what does he say? The pressure varies inversely with the volume. That means he says the process, the hint for the identification of the process is the pressure varies inversely to the volume. Name the process where the pressure varies inversely to the volume. Any guess?
Isothermal.
That's great. So PV is equals to mRT, is it? So when m, r, and t all are constants, so PV is equals to constant. So here the pressure is inversely proportional to the volume. So by this statement, I can say that whatever the process he is insisting is your isothermal process. Okay. Now, in the isothermal process, how does it look on a PV diagram? It's a curve, is it? Yeah, it's a curve like this. Okay. Now, just a minute. Okay. Yes, it is an isothermal process. Now we have to decide whether it goes, whether my state 1 is here and state 2 is here and it goes in this direction, or whether my state 1 is here or here and it goes in this direction. How do I come to a conclusion about this? You know very well about the initial state, is it? So for this, again, I will be drawing the state table. State 1, state 2, okay, where state 1 is your initial thing and state 2 is your final thing. Again, I have the values of pressure and volumes here. Okay, initial state will remain the same. Initial state will remain the same. So it is how much? 210 kPa. So it is 210 into 10 to the power of 3 in terms of Newton per meter square. Okay. And initial volume is also same, 0.04. And final volume is given in the problem, so it is 0.15. The only thing is, I have to judge what is the pressure at the state 2, that is the final state. See, if you observe, you cannot go in the reverse fashion. Let us assume if you cannot decide whether it is going in a straight way or in a reverse way, we shall just assume the things to be like this and calculate the things. Okay. So here, let be state 1 and state 2. Okay. So I'll just take this aside. Now, so with this minimal amount of what you can say, the data, you have the value of P1. Observe this very careful, okay? So you have the value of P1, you have the value of V1, and you have the value of V2. So these three values you have. So what is that expression out of 6 different expressions like this? So 6 different expressions like this, which one I am supposed to consider so that I get the value straight away without calculating the other parameters. So I have 6 different expressions here, yes or no? So it is 1, 2, 3, 4, 5, and 6. So which one should I consider so that I get the value straight? So it is P1, V1, and the V2 are the values which I know. Which one should I consider?
First one.
Yes, the first one, because so P1 you know the value, V1 you know, V2 you know, so that's why the first one I'll be selecting the first one to calculate the isothermal work done. So just go back here and write the same formula. Okay. Now, so work done from 1 to 2, which is isothermal in nature, is given by the first form, which is P1 V1 into ln of V2 by V1. Just substitute the things. P1 is how much? 210 into 10 to the power of 3 into V1 is 0.04 into ln of V2 is 0.15 divided by 0.04. Just give me the value from 1 to 2, which is isothermal in nature. So whatever you get it in joules. Okay. Yes, what's the answer?
So 11,102.75.
Okay, 11,102 0.75. So we can approximately write it as 11 kilojoules, something like that. In and around 11 kilojoules, correct?
Yes, sir.
So that's the end of the problem, guys. So it's all about the application of whatever the information about the process are there with you. So you have to be very perfect regarding the processes, all the 5 processes and their work done formula. Then the process and the flow of a problem will be very easy. Okay, and you don't find any huge formulas in the first 3 modules. It will be just as lengthier as this one that side. So if you remember those without any confusion, then the things are very, very easy. Okay, shall we try the other one? Anyone are just taking it down so that I have to wait? Should I wait or should I go to the next problem? Yes, guys, should I wait or should I move to the next problem? Taken down is over?
Yes, sir.
Okay. So just take this problem. A gas expands from an initial state where the pressure is 340 kPa and the volume is 0.0425 meter cube to a final pressure of 136 kPa. The relationship between the pressure and volume of the gas is PV square is equals to constant. Determine the work done by the process. So that is the question. Okay, so keep taking it. So I will be marking your attendance being by. Abdul Rahiman. Why there is a very less strength today? 28 only people are there.
Placement classes are going on, sir.
Okay. So Abhinav, Adarsh.
Present, sir.
Next, Shanul Mustafa. Mohammad Reza.
Yes, sir.
Akshay. Amit S. Lahari.
Present, sir.
Next, Amrut Acharya. Amrut M. Acharya. Anvit. Ashwin. Ashwita. Chandan C.
Present, sir.
Yeah. Chandan C. Benoy D'Souza.
Present, sir.
So why were you absent for the last 2 classes, Benoy?
So last class I was there, but midway my phone just turned off. And the previous
Okay.
class before that I wasn't. I had a migraine kind of thing.
Okay. Take care. Next, okay, completed. Taking down the problem. Shall we solve it? Yeah.
Yes, sir.
Okay. I need everyone to respond, man. Not only Sabet or few people. I want everyone to respond. Okay. So since these problems are a little bit new things to be learned, so you will learn better if you respond better. Okay. Now, so first, whatever might be the problems on the work done, first you have to decide which process it is. Okay, which process it is. Based on that particular thing, you can carry on to the PV diagram, formulas and all. Okay. Okay. Now, yes. Can I get answers from you? Like details of inverters because for your course. Can I get the answers from you? Which kind of process is this? Whatever the statements which he has given. Can you identify the process? Yeah. Any clue he has given to identify that the problem is on this particular process?
So isochoric.
Isochoric. So Benoy, so why do you think it is isochoric?
Because they've written either the relationship between the pressure and volume of the given gas PV square.
Is PV square that is equal to constant. They have given it, right? So any process can be represented by using an equation PV to the power of K that is equals to constant, correct? So now in such case here the value of K is 2 just by correlating these two expressions. So what is that particular process where the value will be equal to 2, which is some number apart from 0, apart from 1, apart from infinite, or being the value of gamma, it is something other number which is 2, which is given in the problem. Now identify the process. Which process?
Polytropic.
Exactly. So it is a polytropic process. Any doubts in identifying so? So if you just consider this particular thing here, PV square is equals to constant. So by that thing, the value of K you have find out as 2. So which is not 0, which is not 1, which is not infinite. Okay. Which is not equal to the ratio of specific heats, by the way, 1.4. So it is a polytropic process. Now, how does a polytropic process look in a PV diagram? So just plot it out. So it looks as this. So before deciding the states, whether the state 1 would come here or whether the state 2 would come here, we shall again go in depth within the problem statements again, once again. Okay. Should I keep it or not? Let it be. Okay. Now, see, he says the gas expands here. Okay, in this particular thing here. So he says the gas expands from the initial state where the pressure is. Okay, so again we shall write the state table now. Okay, so state 1, I'll be just writing 1 because it is understood that it is state 1. Okay, state 2. Okay, and the values of P and the values of V have to form a table like this, correct? Now, what he has given. From an initial state where the pressure is 340 kPa, that means the initial state pressure is how much? 340 into 10 to the power of 3 Newton per meter square. Okay, that he has given. And the volume is 0.0425 meter cube. So initial volume he has given, which is 0.0425 meter cube. To a final pressure of 136, final in the sense the state 2, that is 136 into 10 to the power of 3 is your final pressure. Okay. The relationship again he has mentioned about the process. See, he wants the work done from the process 1 to 2. So we have decided it to be a polytropic process. Okay. We have decided it to be a polytropic process by the expression which he has given. And the polytropic work done is given by P1 V1 minus P2 V2 divided by N minus 1. So here the value of N is nothing but 2. Okay. Because K is equals to PV to the power of N is equals to constant is an expression which denotes the polytropic process. So the value of N is 2. I can just write it here directly. So PV to the power of N is equals to constant. He has given PV square is equals to constant. Therefore, N is equal to 2. Okay. Now, carefully observe this. If the gas expands, whether the pressure would increase or decrease. Yes, guys. If the gas expand, whether the pressure would increase or decrease. Okay, let me go in the other way. If the gas is compressed, then the pressure would increase or decrease. Yes, the pressure would increase, correct? So when it is a compression, when it is a compression, what happens? The pressure level rises from here to here. So pressure level rises like this. If the pressure level rises, that indicates your state 1 should be here and your state 2 should be here, because the compression, the pressure gets increased like this. Yes? Okay. Now, the opposite of your compression is your expansion. Am I right? So it is expansion. So if it is an expansion process, what happens to the pressure? Pressure gets what happens in an expansion process? In the compression process, the pressure gets increased, whereas in the expansion process, pressure will get decreased. Okay, pressure drops in an expansion process. That means you have to form a state 1 and state 2 in such a way that pressure drops. So this will be your state 1 and here will be your state 2, so that the pressure gets dropped from state 1 to state 2 like this. When you observe on the PV diagram like this. Okay, the pressure gets dropped from state 1 to state 2 like this. Any doubts, guys, in this? In deciding, since if it is an expansion process, you have to take it as this way. Okay, if it is an expansion process. Okay, if it is a compression process, you have to take it in this way. Any doubts? In identifying compression and expansion?
No.
Clear, right? So come back to the present problem now here. So he says the gas expands. That means it is an expansion process. Where should my state 1 come? Whether it is in the bottom or it is in the top. Where is my state 1? Where is my initial state now? Since it is an expansion process. Yes, exactly. So the state 1 would be at the top and state 2 would be at the bottom, where the gas expands from state 1 to state 2, thereby decreasing its pressure gradually like this. Okay. Clear? Until now? Okay. Yes. Yes. So we'll just add up another page. Okay. So once this is done, there is something known as, this is very, very important, just observe it. Okay. There is something known as PVT conversion equations. Okay. What are these equations all about? First of all, let us come back to this particular problem here. So I said I can calculate this is a polytropic process. We have decided, yes, this is a polytropic process. Second thing, we have decided that it is an expansion process. So the state 1 is at the top and the state 2 is at the bottom. The pressure will start decreasing from state 1 to state 2 and your volume will start increasing from state 1 to state 2 like this. So pressure gets decreased and the volume gets increased. So this is what happened in a polytropic process. We have analyzed it and we have noted that the polytropic work done is given by P1 V1 minus P2 V2 divided by N minus 1. Okay, we have noted down it also. Okay, now in order to calculate work done, what is the hindrance that I observe? That means what is the lack of the parameters that I observe? Do I have the value of P1? Yes, I have the value of P1, correct? Do I have the value of V1? Do I have the value of V1? Yes or no?
Yes.
So the value of V1 is there. Do I have the value of P2?
Yes.
So you have the value of P2 here. Okay. Do I have the value of N?
Yes.
So N is also there. So do I have the value of V2?
No.
So I need to calculate somehow the value of V2, is it? So in order to calculate the value of V2, we must come across a concept known as a PVT conversion equations. Okay, we shall see what it is. So there are again a 5 process. So I'll be explaining for all the processes. Isochoric process, isothermal, adiabatic, and your polytropic. Okay, you know all the data. What is the value of K? Which parameter is constant? How does it look on a PV diagram? What is the expression to calculate your work done? You know up till now. Now we have to understand what is the PVT conversion equation. So for isobaric, isochoric, and isothermal, there is a common expression which can be used to determine the different parameters. That is P1 V1 by T1 is equals to P2 V2 by T2. Okay, just note down this expression. The usage of this is, see, some parameters would be known for state 1, some parameters would be known for state 2. Okay, in state 2, if volume is missing, you guess. In state 2, if volume is missing. So you can use this expression for all these 3 processes to get the value of V2. That is what I say PVT conversion equation. Got it? So we shall see the usage of it. Just note down this expression. So for an isobaric and isochoric and isothermal, the PVT conversion equation is given by P1 V1 by T1, that is equals to P2 V2 by T2. For an adiabatic process, the PVT conversion equation is given by P1 by P2 is equals to V2 by V1 whole to the power of gamma, that is equal to T1 by T2 whole to the power of gamma divided by gamma minus 1. So this is the expression used to convert the different parameters of state 1 and state 2. So what it says is P1 by P2, I said you, it is always P1 by P2. It is always V2 by V1. Wherever you go in the thermodynamics. So it is always V2 by V1 and it is always P1 by P2. So it is P1 by P2 is equals to V2 by V1 whole to the power of gamma, and the pressure and temperature are corresponding. Okay, so T1 by T2 whole to the power of gamma divided by gamma minus 1. Same it goes with the polytropic process also. I said you have to replace gamma with N. So it is P1 by P2 is equals to V2 by V1 whole to the power of N. That is equal to T1 by T2 whole to the power of N divided by N minus 1. Okay, so this is the temperature, pressure, volume conversion equation, that is PVT conversion equations for a polytropic process. Okay, Ramdas.
Yes, sir.
Ramdas Emmer. So what is the PVT conversion equation for an adiabatic process?
V2
Just
V2 by
first
V1.
P, first go with P, next V, next T.
Okay.
Okay.
P1 by P2 is equal to V2 by V1 to the power y
Whole to the power of gamma.
whole to the power of gamma.
That is
Equal to T1 by T2 whole to the power
whole
of
to the power
gamma
of divided
by
by
gamma minus 1.
exactly. Rohan Pradeep. Rohan Pradeep. Rohan Pradeep. Not there. Rohan. Okay, next is Shahzad Abdullah.
Yes, sir.
So give me the PVT conversion equation for an isochoric process.
P1 V1 by T1 is equal to P2 V2 by T2.
For an isobaric process.
P1 V1 by T1 is equal to P2 V2 by P2.
And for the isothermal, it is the same thing. Yes, Sujay Shetty. Sujay Shetty. Okay, he's also not there. Sujay. Next is Tejas Shetty. Tejas Shetty. Yes, man. Give me the expression for PVT conversion equation in a polytropic process.
P1 by P2 is equals to V2 by
P2 by
V1 the
V1.
whole power n is equals to
Mhm.
T2 by T1 by T2 the whole power n minus 1.
Okay. N divided by n minus 1. Okay. Okay. Just a little. Okay. So what is the PVT conversion equation for a polytropic process? For polytropic process, okay, for polytropic process, we know that P1 by P2 is equals to V2 by V1 whole to the power of gamma, not gamma here, it is n, that is equal to T1 by T2 whole to the power of n divided by n minus 1. Now, I am correlating here the pressures and volumes, yes, between state 1 and state 2. So, if I consider these two, okay, just these two here. So, what happens? It is just P1 by P2, that is equals to V2 by V1 whole to the power of gamma. Okay. Now, I want the value of V2, right? V2 is unknown here. So, V2 is unknown. So, what I will be doing, I should extract the value of V2 here. Okay. So, how do you extract? If I send n to the either side, what does it become? It becomes 1 by n. So, it is 1 by n here, V2 by V1. Okay. From this, V2 is equals to V1 into P1 by P2 whole to the power of 1 by n. Correct? Yes?
Yes, sir.
So just substitute the values. What is the value of V1? V1 is how much? 0.0425 into P1. P1 value is 340 into 10 to the power of 3 divided by 136 into 10 to the power of 3 whole to the power of 1 by 2, because 2 n value was 2 here. So now I will be getting the value of V2. What is the value of V2, guys? Yes, what is the value of V2? Namita? What
Yes,
is the
sir.
value of V2?
Is it 0.053125?
3.05?
3125.
3125. Is this the value you are getting?
Yes, sir.
Into 10 to the power of 3 something? 10 to the power of minus.
I think I don't have a proper calculator, so I'm not exactly sure whether it's correct or not.
Okay. So why don't you have your calci, Namita? Sorry.
No.
Yes, Namita.
Still.
Okay. Get the calci from the next class. For the next class, okay? Yeah.
So it's
Any
in the
other?
hostel.
Okay, it's in the hostel. You can even download an app, okay, HyperCalc. There are many apps. You can use that in your Android phone also. Okay.
Okay, sir.
Okay. Any other answers, guys? Let me close the class fast. Answers for V2. What's so difficult in calculating this? I'm not getting. .982 Saurabha. So I don't have an answers here, man. I just have a questions of it. So let me check. Okay, 0.982. Is that correct? Anyone else got this answer? Javel?
Yes, sir.
What is the answer? Is that correct? 0.982?
Sir, I got the answer 0.0671.
You have to say no when you got the answer. What, Javel?
Okay, sir.
Okay, what is the answer you have got?
0.0671.
671. Okay. Any other answers, man? Which one is correct? Javel's or who has given this answer? Saurabh's. Which one is correct? Benoy? Adarsh DS? Adarsh. 0.67. Even you got the same, Nashad? Okay, so since two of them have responded, okay, even the others also 0.671. So this is the answer, man. Just substitute rightly, you'll get the answers rightly. So substitute in this particular equation for the polytropic process, P1, V1 minus P2, V2 by N minus 1. Okay, so only V2 was unknown. V2 we have just calculated here. Just write the things there, 0.0671, and calculate the work done in joules or kilojoules. Okay, and meanwhile give your attendance. 0.0671. Okay, that is the value of V2. Now calculate the work done from 1 to 2, which is polytropic. I have substituted the things for you. Okay, just substitute the values of P1, P2, V1, V2. That's it. Nothing there in that. Next is Abdul Rahman. Oh, I have no.
Yes, sir.
So I have marked the answer. Let's see this thing attendance, right?
No, sir. I didn't.
Okay, fine. I'll just call upon once again. Abdul Rahman, Abhinav, Adarsh.
Present, sir.
Okay, Adarsh is there.
Yes, sir.
Ashanul, okay. Ahmad Reza, present. Akshay.
Yes, sir.
Akshay is not there. Amit Aslahari.
Present, sir.
Okay, Amrit. Amrit. Next is Anvit Ashwin. Ashwita is there. Chandan, I have taken all this. Okay, I have left from here. Faizan Muhammad. Gaurav. Gaurav. Gautam.
Yes, sir.
Javel is there. M. Karthik. M. Karthik, not there. Fazil.
Yes, sir.
Okay. Sihab. Muhammad Sihab. Tausif Ali. Muwaz. Yen Suraj. Nafa Abdul. Many are not there man, today. Namita.
Present, sir.
Okay. Next is Nandish. Nathan. Niharika. Nishchit. Oh my god. Nitin. Omkar. Prarthan.
Present, sir.
Pratish C. Suvarna.
Present.
Prajat.
Present, sir.
And Ramdas.
Yes, sir.
Ranjat. Shabat.
Present, sir.
Sacharya. Shahzad Abdullah.
Present, sir.
Okay. Shashank. Shashank. Next is Shakti Tejas. Shravan Kumar. Niharika, where were you when I called you?
Sir, I told
Sure.
present, sir, in the text box.
Okay, in the text box you have said, no issue. But Shetty Sujay, I marked you absent when because you have not responded here. Next is Shetty Tejas, Shravan Kumar, Sriraj, Saurabha, Sumant.
Present, sir.
Saurabha is there, okay. Sumant, Varun, Vitneshwara, Amit Sangolli,
Yes, sir.
Nille. Amit Sangolli
Yes, sir.
is there. Okay, Nilesh is there. Prajwal Hegade, Sandesh, Rachan, Rohan. Rohana marks the absent. Varun. Adarsh.
Yes, sir.
Adarsh is there. Sampreet and Muhammad Amin.
Excuse me, sir.
Yes, Numan.
You didn't call my name, I guess.
Okay, your name is not listed here, man, in the list. Why is that? So I'll just clarify. Okay.
Okay.
Okay. Fine.
Thanks. Yes.
Next, you have got the answer for this? What is the answer? Okay, I don't have an answer. So 5324.4. Is that the right answer? And everyone got the same answer? Yeah? Everyone got the same answer? Amit Lahari, Amit Sangolli, both of you men. You got the same answer?
Yes, sir. Same answer.
How much?
5324.
Okay, so this is how you solve the problems on different processes. We shall see still more problems in the coming classes. Okay. So most probably in 2 to 3 days after this class is completed, I require another 2 classes for the problems. After that, you might have to submit your notes, whichever you have written. So I will raise the request in the Google Classroom. Okay. Take care, guys, until then. Okay. See you soon.
Thank you, sir.
Yeah.
Thank you, sir.
Yes. Thank you.